Hi everyone, and welcome back. So what we're going to be focusing on today are just more practice with graphing piecewise functions. So if I look at the first one, so it says graph f of x equals 3. Well, I want you guys to remember, f of x, what variable does f of x represent? F of x is another way of saying y. So this is saying graph y equals 3. So what you should be doing is typing this into the calculator. So you should be graphing when y equals 3. Now notice this is a constant value. So we're going to end up getting a straight line. Whether it's horizontal or vertical, you're going to tell me. So graph that in the calculator and see what you get. Okay, good. You get a horizontal line at y equaling 3. So there's y equals 3. Okay. All right, let's take a look at letter B. So for letter B, I want you to tell me, what kind of function is this? Is this linear? Is this cubic? Is this quadratic, exponential? What is this? This is quadratic because of the x squared. So we know we're graphing a quadratic function. And again, guys, I'm putting this straight in my calculator. Y equals 1/2 x squared because we can rewrite f of x as y. It's always the output. All right, so maybe pause the video here and just graph those points here. Just graph a few, maybe about 5. Let's graph 5 points. All right, so there is my graph of the quadratic function. Don't forget the arrows on either end because it continues on in the upwards direction towards infinity. All right, so let's look at letter C. We want to graph f of x equals negative x plus 1. So again, remember, this f of x is really just y. Y equals. So we're going to graph in our calculator y equals negative x plus 1. Type that in the calculator. All right, now you should have noticed that this is a linear function. So this is linear. The degree of this function is 1, right? We could really say this is negative x to the first. We know the slope is equal to negative 1, right? That negative 1 out front. And our y-intercept is positive 1. So that's my y-intercept. So I'm starting up at 1, and I'm going down 1, right 1, down 1, right 1, down 1, right 1. We're continuing that in both directions. Which again, guys, you could just plug this in the calculator and graph. All right. And connect that with a nice straight line. Okay. So now part D says, in words, what do the following inequalities mean? So here, for the first one, take a second, read it over, and see if you know what this actually means. This means x is less than or equal to negative 3. And we include negative 3. All right, so again, we have x is less than or equal to negative 3, where we're including negative 3. Now for the next one, remember if we draw that number line, we're going from negative 3 to positive 2, where 2 is included. Negative 3 is not. It has that open circle. So in your own words, we have x is between negative 3 and 2, and we're not including negative 3. That's in your own words. X is between negative 3 and 2, but we don't include negative 3. Okay, and then lastly, here we have x is greater than 2, and we do not include 2. Do not include 2, which makes sense. If you want a number bigger than 2, 2 is not bigger than 2, so we do not include 2. All right? Okay, so I just kind of broke that out for us. All right, so now next part, we're actually going to graph all of these. So let's do this one at a time. We're going to graph the first example. So that was up here, letter A. We're graphing f of x equaling 3, where x is less than or equal to negative 3. So that's if x is less than or equal to negative 3. So from my graph from the top, we are only going to be looking at where is x -3. So that's here, right? So I'm only graphing from this point on to the left. So that's what I'm going to graph. I'm going to go over to -3. I'm going to go up 1, 2, 3. Got my closed circle, and I'm traveling all the way to the left. That's part 1. Part 2 now says we're going to graph 1/2 x squared, and it's going to be graphed between -3 and +2. So let's graph that between -3 and +2. So now when I come back up to my graph, up here, we are looking at this only between -3, so that's here when x is -3, and when x is 2. So I'm only going to be graphing what I see in between here. That's the only part of the graph I'll see. So let's do that between -3 and +2. Now just be careful because at -3, remember there's that open circle because of the no underline here. Okay? And then the very last thing we need to do is graph when I have x is greater than 2. So I'm looking from this graph for all the values where x is bigger than 2. And that's these values here. It's the only thing I'm looking at. So here I have a point at 2, -1, 2, -1. I have 3, -2, 3, -2, and continue that pattern. Again, remember, notice the open circle because there is no, it's not greater than or equals to. That would mean it's closed. Because it's greater than, it's just an open circle. Okay? So this is what my piecewise function would look like if I graphed all of those pieces together. All right, so let's keep moving on. This is just our first round of practicing graphing piecewise functions. So if I look now at the next page, at my next exercise, all right, we have here, given the piecewise function, evaluate each of the following. So let's look at the first one. We have g of -2. Well, that means when x equals -2, figure out whether that's applicable to the top line or the bottom. So if x is equal to -2, well, let's see. If I plug in x here, is -2 less than 0? Yeah. So I'm looking at this top line here. So we're going to plug in, now we're using this left-hand side, -2, which is just 2. Let's check now g of 0, where x now equals 0. So let's see, we're plugging in x to be 0. Is 0 less than 0 or 0 greater than or equal to 0? Good, 0 is greater than or equal to 0. So now I'm looking at the bottom line where I'm plugging in for this x value. So I have 0 plus 3, which is just 3. All right, and then last one, we have g of 4, where x is now equal to 4. Okay, and we just got to check. Are we plugging in that x equaling 4? Let's see, is 4 less than 0 or is 4 greater than or equal to 0? So is 4 less than 0 or is 4 greater than or equal to 0? 4 is greater than or equal to 0, so we're looking at the bottom line. I'm looking right here. So we're just going to plug in 4 plus 3, which is 7. Okay. Now the next part says we're going to graph these. So graph the piecewise functions on the defined axis by using the steps provided. Okay, so let's fill in the table for g of x equaling -x. So now, right now, we're going to look at that top line. So we're looking at where all the x values are less than 0. Notice how 0 has that open circle because it's less than. This has less than involved in it. Okay? All right. So let's plug in. If I have to plug in for -x, this can go straight in the calculator. Remember, g of x is also another way of saying y equals. So -0 is 0, Negative negative 1 is 1. Negative negative 2 is 2. Negative negative 3 is 3. And negative negative 4 is 4. So I'm going to graph those points. So I have 0, 0 has an open circle. Negative 1, 1, that's just a point. Negative 2, 2 is a point. Negative 3, 3, and negative 4, 4. Now, notice the arrow, because this is all values less than 0. So to go towards negative infinity, we include that arrow. All right, now we want to take a look at the next piece. We want to fill in the table for g of x plus 3. So if we just quickly look back at this piecewise function, g of x equaling x plus 3, that's now the bottom part. So now I'm looking at plugging in for y to equal 3 on my calc for all values where x is greater than or equal to 0. Because it's greater than or equal to, we get that closed circle. So I'll write that here again. Closed circle, that means including, which we use for greater than or equal to or less than or equal to. And then the open circle means not including, which would be greater than or less than. Okay? All right. So now we're looking at this bottom part of the piecewise function. So we're looking here. So if I want all the x values greater than or equal to 0, we have that closed circle. And we want them all to be greater. So we're going to go towards positive infinity. Get that arrow. So let's plug in. When x is 0, 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. 3 plus 3 is 6. And 4 plus 3 is 7. So now I'm going to plot all of these points. So I have 0, 3. 0, 3 with that closed circle. I have 1, 4. 2, 5. 3, 6. And 4, 7. And remember that arrow at the end. So there's my piecewise function, guys. This actually was on a Regents. This was actually a Regents question. There's just a little bit more scaffold here. All they gave you was this information and they just said graph it. All right. Okay. And just don't forget to label it. So this is just g of x. Okay. Let's move on to some more examples here. So let's flip over to the next page now. So now we have f of x. So we're given another piecewise function. Again, we analyze row by row. Remember that. Row by row. You deal with what's on the right-hand side first, and then what's to the left, that comes second. All right, so we're just going to get a little bit more practice here. So f of 2, that means x equals 2. When x equals 2, I am looking at the top of the bottom line. So let's see. Is 2 less than or equal to negative 2? Or is 2 greater than or equal to negative 2? So that means we're looking at the bottom line. 2 is greater than negative 2. So I'm plugging in 2 times 2 plus 4, which is 8. Okay, let's take a look at the next one. Now I have x equals negative 2. So is negative 2 less than or equal to negative 2? Or is negative 2 greater than negative 2? Negative 2 is less than or equal to negative 2. So my answer is negative 3. Just copying from what's on the second-hand side. Okay. Okay, and lastly, f of negative 4. So that means now x equals negative 4. When x equals negative 4, well, let's see. Is negative 4 less than or equal to negative 2, or is negative 4 bigger than negative 2? Careful here. Negative 4 is less than or equal to negative 2. So my answer here again is negative 3. Okay, so now we actually want to graph this. So again, we have these divvied up. I color-coded them here in red. So here I have my red. We'll graph here in red for the first function and then in blue for the second function. Okay, so for the first one, we're going to graph f of x equals negative 3, where x is less than or equal to negative 2. For the second one, we're graphing f of x equals 2x plus 4, where x is greater than negative 2. So if I'm looking at all my x values being less than or equal to -2 for the first one, remember that closed circle with the arrow. So I have -2, -3, -4, -5, -6, -7, -8. The output is always this -3. So all of my y values are -3. So let's actually plot this. So -2, -3 has a closed, circle, and all of my y values are at -3. All of them to the left are at -3. So there you have part of the graph. And maybe make yours a little bit neater than mine. Okay. Now the next one, for f of x equaling 2x plus 4, we're looking for all the values where now x is greater than -2. So I have -2, -1, 0, 1, 2, 3, 4, and we can keep going, right? That's why we go towards infinity. And remember, it's greater than, so this is going to be an open circle here. All right, so now what you guys should be doing is plugging this into the calculator. So we're going to plug in 2x plus 4, and you're going to tell me those y values, so do that for me. Okay, good. So you should have had 0, 2, 4, 6, 8, 10, and 12. And again, you could have plotted more points if you wanted. So when I come over to -2, 0, we have an open circle. I have -1, 2. I have 0, 4, 1, 6, 2, 8, 3, 10. And I'm going to stop there because 4, 12 will not fit on the page. And with your best of your abilities, make that a nice straight line. And we're just going to title this f of x. So that's how we label it. Label it f of x. Okay? So that's what your graph for the piecewise function is going to look like. I want you to try question 2 on your own without me. So you'll pause the video for question 2 here. You might want to refer to what I have for number 1. Pause the video here and see if you can fill in the tables here on the left. I'm sorry, on the right. Fill in the tables on the right. See if you can come up with the information to graph it. We'll answer these questions together. And I'll do that color coding here for you, for those of you that like to color code your notes. All right, so see if you can graph this. Come up with a table. Okay, so that first and foremost should be what your two tables look like. And I'll include a little bit more info up here. This was for f of x equaling x plus 2, where x is less than 1. Okay, so this is what your two tables should look like. Okay, now we should graph these. So I'm going to come over to 1, 3, and I'm going to put my open circle. 0, 2 is just a point. -1, 1 is a point. -2, 0 is a point. -3, -1 is a point. -4, -2 is a point. And -5, -3 is a point. So I'm just going to connect these with a nice straight line as best I can. And now I'm going to graph the red function. So we have a point at 1, -5 that has that closed circle. I have 2, -5, 3, -5, 4, -5, 5, -5, 6, -5, 7, -5, and it continues. It goes on. So I'm going to draw my nice straight line connecting these points. And I'm just going to label, this is the function f of x. This whole thing, this piecewise function. This whole thing. So now we want to come up with the domain and range. So domain and range, remember domain, those are your x values. Range is the y values. So if we think about this, the domain, so let's travel from left to right. So as we travel from left to right, I'm including all those negative values, all negative values. Stop, because look at what we have here. There is that hole in the graph up here, but notice how it's actually really filled down here, right? It's filled here. And as we continue again back to going to the right, all values are included. So our domain is all real numbers. Now, as far as the range goes, we want to go from bottom to top. So as I travel from the bottom all the way to the top, stop here. What's that y value? I went from -infinity towards what? What's this y value? 3. But now am I actually touching 3? No, because of the open circle. So our y values are all values less than 3. Okay? All right. Let's take a look at letter B. We want the x and y, just x-intercepts. So our x-intercepts, where this crosses the x-axis, is right here at -2, and that's it, when x equals -2. And over what interval is the function increasing? So as we go from left to right, where is it increasing? So I'll highlight over our two sections. Is it increasing from here to here? Or is it increasing from here to here? Well, this is just a flat line. That's not increasing or decreasing. But as I go from left to right, from here to here, that's increasing. So as we travel from -infinity towards +1, that's where my function is increasing as I go from -infinity all the way to +1. Awesome. Okay, let's continue. Let's just get a little bit more practice in and you guys should be all good to go. So let's take a look at question 3. We want to graph the following piecewise function on the axes below. So again, I'm going to highlight the graphs I'm going to be creating. So let's highlight the first one. So we'll make this one done in green and we'll do this one in red. So we'll do that one here. And I'm just going to label that this function, we have f of x is equal to -4x plus 2. And then here I have f of x equals 2x plus 5. And notice the interval. So we're going from -5, -4, -3, -2, -1, 0, 1. So we're between -5 and 1. And then for the second graph, we're between 1 and 3. So I have 1, 2, 3. Okay? And I want to take a look at those open, so the open circle versus the closed circle. So we have an open circle, remember, when it's greater than or less than. We have the closed circle if it's greater than or equal to or less than or equal to. So if I look for what I have here in green, we have -5 is less than or equal to. So this less than or equal to here means we're going to have a closed circle. And now notice the difference. When x is less than 1, we don't have an arrow here. Because we're looking at less than, this is going to have an open circle at 1. Okay? And then lastly, if I look at what I have in red, we're between 1 and 3, where 1 is less than or equal to x. Well, again, this has less than or equal to, so there's that underlined piece, so there's a closed circle here. And we're going towards 3. And 3, x is less than 3. This is less than. So again, we're dealing with that open circle. Okay, so what you should do right now is fill in those points and then we're going to graph this. All right, so hopefully your points match mine and now we're going to graph these. So notice now there are no arrows on either end. They're either open circles or closed circles. So if I come over to -5, that has a closed circle. If I have -4, -3, that's just a point. -3, -1 is another point. -2, 1 is a point. -1, 3 is a point. 0, 5 is a point, also the y-intercept. And then we have a point at 1, 7 where that has the open circle. So we're going to connect those with a nice straight line. Now I'm going to graph the next piece. I have 1, -2, which has a closed circle. I have 2, -6, which is just a point. And then I have 3, -10, which is an open circle. And we're connecting these again with a nice straight line. Last thing that you have to do is just label the function. So we're just going to call this f of x. So what I would encourage you to do is try to pause the video here, either if you need to rewind, recap what we just went over, because you're going to do question 4 here on your own. So pause the video here if you need to rewind and try number 4 here on your own. I'll post the solutions in a moment. Okay, so that's what your graph should look like for h of x, your piecewise function. We can do this part together. Let's state the y-intercept for the function. So the y-intercept is when x equals 0. Remember, if I said find the x-intercept, you will remember x-intercept is when y equals 0. Remember that x-intercept is talking about the roots. So if I ask for the y-intercept, you have to remember that's when x equals 0. So when x equals 0, my y value is right here, and that's when y is equal to 4. So we have y equals 4. All right, now for domain and range, remember we said domain are the x values, range is the y values. So as we travel from left to right, we want to see what are the x values. So I have an x value here when x is -4. So for the domain, I have -4, and I'm including that point, so I'm including -4. And I go all the way over to when x equals 5, and I'm including 5. So that's my domain between -4 and +5. Now my range is when I'm talking about the y values. So y values are up and down. So from -infinity to +infinity, we want to check where we have actual points. So as I travel up, I see I have a point between here and here. So my range is from -4, I'm including -4, and I'm also including this y value, which is at 6. So this is my range from -4 to +6. All right, and we're just going to wrap it up with a few quick word problems. So I want you to scroll through, and I want you to take a look at question number 10 here. So question number 10 says, at a local movie theater, the cost of a movie ticket can be represented by the function. So we need to understand what this means. This means that the movie ticket will cost $7.50 if you're between the age of 0 and 12. So really, if you were younger than 12 or equal to the age of 12. So that means age 12. It's $10.25 if you are between the ages of 12 and 65. And then it's $9 if you are a senior citizen. Okay. So the question says, what is the cost of a movie ticket for a 12-year-old child? So if you are 12 years old, we got to be careful. Are you looking at this first row or the second row? You are equal to 12 years old. You are 12 years old. Notice the equals to here and not here. So it's going to cost $7.50. And that's it. That's all you have to do for this problem. Okay, let's take a look at another example. So for question 11, we have Erin buys gas at a self-serve gas station for $2.75 a gallon. Ooh, yikes, that's high. Okay, we have the gas station has a promotion going on. For anyone that buys more than 10 gallons of gas, they only have to pay $2.25 a gallon. And here is the piecewise function. So how we read this is it's $2.75 a gallon if I buy between 0 and 10 gallons. So if I buy between 0 and 10 gallons, it's $2.75 a gallon. However, if I buy more than 10 gallons, it's going to be $2.25 a gallon. So the question says, explain this piecewise function, how it represents the situation. Well, we just kind of said this. It's $2.75 a gallon if you buy between 0 and 10 gallons. It's $2.25 a gallon if you buy more than 10 gallons. That's our explanation. So it's $2.75 a gallon if you buy between 0 and 10 gallons, and then it's $2.25 a gallon if you buy more than 10 gallons. So this C of G represents the cost, right? This represents the cost, total cost in dollars, and G represents the number of gallons. It's important you guys understand the variables. Now, lastly, I want to know how much money would someone pay if they buy 14 gallons of gas during this promotion. So 14 gallons, what we got to remember, is 14 between 0 and 10, or is 14 bigger than 10? 14 is bigger than 10, so I'm looking at the bottom line. So I have 225 times 14, because I'm plugging in G equals 14, and I end up getting $31.50. So that's my final answer. That's how much you'll pay for 14 gallons of gas during this promotion. All right, so I hope you guys found this video helpful. Be on the lookout for another one coming up on piecewise functions, and you guys should be able to get started with your Delta Math homework. Hope you found this helpful.